Hi folks, my name is Emily Denton, and Timney Gibber and I are organizing this tutorial on fairness, accountability, transparency, and ethics in computer vision. We broke this tutorial up into 3 parts, and this is the final section, so if you haven't already watched the earlier 2 lectures, I recommend you go back and watch those before continuing with this video. In this lecture, I'm going to be attempting to synthesize some of the lessons that we've learned throughout this tutorial, and hopefully point us as a field in the direction of more socially engaged and ethics-informed research practice. Many of the lessons that I'm going to be going through are things that require significant restructuring of the field of computer vision, the way we operate, the incentive structures that are in place, and the way in which we conceptualize and make sense of the work that we're doing. This might seem like a tall order, but I hope I'll also be able to convince you that you personally can play a huge role here. I'm going to be going through some different ways of thinking about your work and also some very concrete steps that you as a researcher and a computer vision engineer can be thinking about. To begin, I'd like to return to a statement that has been recurring throughout this tutorial and that is a fundamental starting point for the rest of this lecture. I hope that if nothing else, you leave this tutorial convinced that technology is not value neutral. It's political. To say technology is political is not to suggest that it has some kind of inherent partisan associations. Rather, it's an acknowledgement that the research agendas that we pursue, the methods and methodologies that we adopt, the technologies that we create, these are all value-laden and impossible to isolate from the social relations that structure our society. The belief that technology is value neutral is still far too common within computer vision and machine learning as a whole. I would encourage folks to read this article by Ben Green here in full. For now, I'll just summarize some of the key points. One of the key arguments for the neutrality of technology appeals to the fact that underlying methods and approaches that scientists and engineers develop can be used for good or bad or something in between, and thus it's simply not the job of the researcher or developer to consider these downstream use cases. This is, in effect, a method of absolving researchers of responsibility, offloading the consequences and impact of their work to someone else down the line. While it is true that many underlying methods can be leveraged for both oppressive or liberatory aims, that does not mean that work on such methods is somehow neutral. To understand why, one must first attend to and recognize that we live in a society structured by interlocking systems of inequality and oppression that give rise to systematic and differential allocation of power, privilege, and resources. Critically, research and development of AI technology and computer vision technology doesn't somehow exist outside of these social relations, but instead it's deeply embedded within and tangled within them. Researchers and developers inevitably embed values, norms, and assumptions, many of which might reflect the dominant norms of a given society, within the research and technologies that they produce. For many technologists, some norms and values may not even be visible, but this doesn't mean that they're not there. And part of the work that we're trying to do with this tutorial is to help render them visible. The incentive structures that drive research and development at both a personal and institutional level also cannot be separated from these broader social relations. The entities that are funding and driving research, and the institutional forces that structure what machine learning and computer vision communities value also themselves tend to be reflective of existing power differentials in the world. To take a concrete example, one might theoretically conceive of uses of facial analysis technology in applications that support communities towards liberatory and anti-oppressive aims. But in practice, facial analysis technologies are currently being weaponized against communities that are already disempowered in our current society. Developing facial analysis technology and remaining agnostic to its use is then not an apolitical endeavor. Not only is neutrality an unachievable goal, but claims to neutrality are themselves politically charged. Without explicit acknowledgement of the political nature of this work, and without practices that work to counter the status quo, we end up simply perpetuating it. And keep in mind that the status quo is one that often upholds racist, sexist, cissexist, classist, ableist, and other oppressive structures. Ben Green puts it quite well. Neutrality may appear to be apolitical, but that is only because hegemonic power manifests pervasively without appearing explicitly political. Anything that challenges the status quo, which efforts to promote social justice must by definition do, will therefore be seen as political. But efforts to reform are no more political than efforts to resist reform, or even the choice simply not to act, both of which preserve existing systems. As computer vision researchers and developers, we all have a role to play in recognizing the political nature of our work. Not only are computer vision technologies and application areas politically charged, but politics are also embedded within the more basic aspects of computer vision as a discipline. For example, this great work on value-laden disciplinary shifts in machine learning details how certain disciplinary commitments to model types, for example, a commitment to deep learning as a method, is in fact entangled with compute and data-rich environments, which themselves embed a particular set of social and political values relating to centralization of power, privacy, and environmental concerns. Metrics of success and other model evaluation criterion also embed certain types of values. For example, equating state-of-the-art of a particular benchmark with progress in a field is itself not a value-neutral position. The argument for political neutrality is itself deeply rooted in an ethos of objectivity, often described as the view from nowhere, which frames scientific practice as neutral, objective, and perspectiveless. Although this framework has been thoroughly critiqued over the years, most notably by feminist scholars, it still permeates much of scientific practice, and in particular remains the dominant, although unstated, ethos of computer vision. This quote from Ben Green, from the previous paper that I referenced, who in turn is rephrasing an argument by Donna Haraway and other feminist scholars, phrases this quite well. Every aspect of science, broadly conceived, is imbued with characteristics and interests of those who produce it. This does not invalidate every scientific finding as arbitrary or incorrect, but merely points to science's contingency and reliance on its practitioners. All research and engineering are developed within particular institutions and cultures and with particular problems and purposes in mind. With its claim to a universal or impartial view, this view from nowhere ultimately acts to obfuscate the specific position or perspective of those involved. This brings me to the next concept I'd like to introduce, that of positionality. Positionality refers to the way in which our social position, who we are socially, economically, culturally, racially, and so on, shapes our experiences and perspectives of the world. As researchers and developers, everything from the research questions we pursue and the methods and methodologies we leverage is shaped by the social positions and lived experience of those involved. Positionality is not about an individual or individual choices. A researcher can actively work to counter sexist or racist attitudes, but this doesn't undo the impact of the way their gender or race has structured their experiences and worldview. While positionality is not something that we can escape from, it's not a type of bias that can be removed. Recognizing and being attentive to how our social position bounds our knowledge is a critical part of socially engaged and responsible computer vision practice. Failure to recognize one's positionality and one's research standpoint will ultimately magnify rather than mitigate its influence on research practice. I now want to turn to a concrete example where the positionality of the researchers involved in a particular project likely contributed to them missing significant harmful impacts of their work. I want to emphasize that these researchers were almost certainly well-intentioned, and so I don't bring up this example to kind of put them on blast or to call out some kind of malicious intent. Rather, I want to emphasize how sometimes, because the folks who are developing technologies are so unrepresentative of the folks who are most likely to be harmed, some potential risks end up being invisible. So the application that I want to focus on is that of generative modeling research that's been conducted in recent years, voice-to-face synthesis. So depending on your positionality, that is, your social position and your lived experiences, you might view this research agenda in some different ways. You might see it as a cool application of generative modeling techniques that you care about advancing. You might see the potential for such methods to be leveraged to filter out voices based on visual cues in a crowd, potentially incorporated as part of an assistive device. You might also see some potential applications relating to surveillance, tracking, and policing practices, which, depending on your personal and community level experiences with policing and state surveillance, might trigger different feelings for you. As I'm sure everyone is acutely aware right now, or at least I hope you're paying attention, Black communities in this country experience terror and violence at the hands of police in a manner that is distinctly different from other communities. This means that, should this technology be incorporated into policing and surveillance practices, we would very likely see harms falling disproportionately on communities that are already over-policed and experience policing and surveillance in distinctly different manners. Finally, if you're a transgender, non-binary, or gender non-conforming individual, you might immediately be struck by the potential for this system to, regardless of application, be exclusionary and harmful to yourself and others. People of all genders present themselves in a myriad of ways. There's no way to unequivocally infer gender from voice or gender from face, and any attempts to do so will necessarily be exclusionary of trans, gender nonconforming folks, and anybody else whose voice deviates from the norm prescribed in whatever data set it's developed from. So how might researchers involved in these works, or for that matter, any researchers who are well-intentioned, well-meaning, but might not have the knowledge or experience to see the far-reaching impacts of their work, how are they to proceed? My primary answer to this, which will manifest in several specific recommendations, is to value the knowledge and experience of marginalized groups and center the perspectives of those most likely to be impacted by technology. We've already discussed how social positions bound and frame knowledge. However, rejecting the myth of a universal perspective, or a view from nowhere, doesn't mean that all partial perspectives are equally valid. Feminist standpoint epistemology tells us that folks belonging to marginalized groups experience the world in ways that gives them access to knowledge that those with the dominant perspective do not have. In other words, marginalized folks have knowledge and experience that is critical to technology developers, and we must be intentionally seeking to include. So what does this actually mean, and how do we achieve it? To start, this means taking diversity and inclusion initiatives seriously. In this figure on the right, Element AI performed recent analysis of the gender diversity of researchers in machine learning. They found only 12% women and have no data for non-binary folks or other gender minorities. We also see a huge gender imbalance amongst professors at leading AI research universities. Again, only binary genders being counted here. When we look at the major tech companies, things aren't much better. Again, still here we're focusing on the single axis of gender. When we look at racial groups employed across various tech companies, we also see abysmal patterns of representation. Additionally, all of these numbers so far only represent single-axis reports. In other words, they only consider an axis of race or gender rather than the intersection of these identities, which of course give rise to unique experiences. Focusing only on the number of folks from different groups who are researchers, professors, tech workers, misses another critical component, namely the experiences that folks existing in this field and holding marginalized identities have. There's many dimensions of this experience that I won't be covering in this talk. But right now, I want to identify one thing of note, namely that the burden of diversity and inclusion efforts tends to fall disproportionately on folks who hold marginalized identities. And it's also these same folks for whom the harms of technology are often the most visible. And in many cases, this is because the harms relate directly to experiences that they've had or experiences that folks in their communities have had. Unfortunately, the extreme homogeneity of the field makes these perspectives few and far between, meaning that the burden of calling them out repeatedly falls on the same folks, those who are themselves most likely to be harmed by the technology. And again, the same folks who are also facing other challenges associated with holding a marginalized identity within this field. This is why it's not only critical to be taking diversity and inclusion efforts seriously, and again, to ensure that it's not only the folks who are already underrepresented in the field who are doing this work, but it's also important for everybody to start thinking about the social implications of their work, again, so that this doesn't continue to fall as a burden for individuals who, have some skin in the game, so to speak. One final thing that I want to say on this front, which again I won't deeply elaborate on and instead will just leave you with some reading material, is that taking diversity and inclusion seriously means actually moving beyond the kind of standard corporate language of diversity and really interrogating the ways in which structural racism, sexism, and other oppressive systems shape academic and industry hiring practices, cultures, and incentive structures, and committing to meaningful engagement with marginalized folks to make action plans for fundamental change. In addition to thinking through who you're personally interacting with and collaborating with, I'd also encourage you to consider at an institutional level whose interests and imperatives are ultimately shaping the field and whose are absent. Where is funding coming from? Who's heading the major research labs? Who's reviewing papers? What are the incentive structures that shape the reviewing and acceptance process? What institutions have the money and resources to progress in a manner that aligns with these established metrics of success in the field? The answers to these questions point to a heavy concentration of power within the hands of a select few, and a select few who are not representative of the most vulnerable and marginalized folks who are going to be impacted by this technology. Okay, so many of these issues are institutional, but that doesn't mean that you as an individual don't have an important role to play. So you personally can do a few things. On a technical level, be sure that you're engaging in ethics-informed model evaluations. For example, make sure you're evaluating your model not only on aggregate statistics, but also on metrics that have been disaggregated across relevant groups. Consider other testing and interpretability methods as well, for example, counterfactual testing and interpretability approaches. And again, make sure that these types of evaluations are informed by the different stakeholders who might be affected by a particular system. Furthermore, make sure that you recognize the limitations of these technical approaches. As we've discussed throughout this entire tutorial, many ethical concerns operate at the level of the task or application area. So please be attentive to the tasks that you're working on, the ethical and political implications of particular applications areas and methods, and be aware that in many instances, simply equalizing error rates or minimizing bias in a very technical sense is not a sufficiently comprehensive assessment of the harms of a particular system. You need to also be attentive at a socio-technical level to the ways in which the system that you're building might ultimately be used and deployed. Model documentation frameworks can also help with this. For example, Model Cards provides a standardized framework for transparent model reporting. For model creators, Model Cards encourage thorough and critical evaluations, encouraging disaggregated evaluations across different groups, as well as discussions of why such groups were chosen and the implications of different error statistics for each of those different groups. Model cards also encourage model creators to outline the potential risks and harms of their work, as well as the implications for use. On the model consumer side, model cards provide information that can greatly facilitate informed decision-making should they adopt that model for a particular purpose. On the dataset side, there's several analogous standardized frameworks for transparent dataset documentation that have been proposed in recent years. A couple of examples of these are data sheets for datasets, which Timnit detailed in an earlier lecture, I think the second lecture of this tutorial on data ethics, as well as some other alternatives such as the nutrition label framework and data statements for NLP. Overall, these frameworks operate in a somewhat analogous way to the model reporting frameworks. For dataset creators, they encourage folks to reflect on the processes of creation, distribution of different groups within their dataset, as well as detailing how datasets will be maintained over time. They also encourage folks to make explicit any underlying assumptions that went into the construction of the dataset, as well as outlining potential risks and harms and implications of use. For dataset consumers, these types of dataset documentation frameworks provide information that can facilitate informed decision making. Again, just echoing some points that were made in the data ethics lecture, both dataset creators and dataset consumers really need to be thinking critically about their choices. Never just adopt a dataset uncritically. Really examine what purpose it was intended to serve, whether it meets your needs, and what the broader social implications might be of adopting this data set for your particular work. Be aware of the limits of your own perspective and understand how your positionality might shape the research questions that you ask, the methods that you adopt, and the way in which you pursue this work. And be aware how some of the ethical considerations might actually be invisible to you. This is really critical when you're thinking through the ethical considerations that you might, for example, put in a model card, or when you're writing your NeurIPS paper and need to think through the ethical considerations to document in your work. Not being aware of the harms of your work does not absolve you from your responsibility. You're still accountable. So I'd encourage everyone to reframe the conversation away from the intents of your work and towards potential impact. Recognizing how positionality bounds knowledge has some implications for how we conduct our work. At the very least, I'd encourage you to be actively following the perspectives of people in marginalized groups that you might not naturally be inclined or incentivized to follow. For example, since grant funding doesn't come from these groups, they're underrepresented or sometimes entirely absent from the scientific review process and the development pipeline. Additionally, as a field, we can, and I would argue we have a moral imperative to shift towards intentional design choices that privilege the perspectives of marginalized stakeholders who are most at risk of being harmed by the technology that we develop. There's many different existing frameworks for what this type of engagement might look like. I give some as examples here. The Design Justice Network is an international community of people who are committed to rethinking technology design in a way that centers folks who are most adversely affected. Their work is intensely participatory and collaborative. The Our Data Bodies Project is another example of a collective that Timney described earlier in a lecture. This is another example of an endeavor that works with communities affected by data-driven systems and AI technologies through participatory, narrative-driven approaches. The Our Data Bodies project also focuses not only on how to empower people to protect themselves from data systems, but also conceptualizes different data futures and advocates for the creation of new tech startups by folks who have been historically underrepresented and marginalized within the field. Generally speaking, these kinds of participatory approaches provide a framework to acknowledge the voice and expertise of marginalized communities, an expertise that is too often missing from the computer vision tools that are being developed today. I also advocate for the field as a whole and you as an individual to value interdisciplinary and non-technical work. Computer vision is simultaneously a technical and a social discipline, though we as a field often forget this, and end up prioritizing, valuing, and incentivizing a very particular type of technical work. Different disciplinary practices also give rise to different types of knowledge. For example, in our data ethics lecture, Timney detailed the lessons that data practitioners can learn and transfer from archival work. Much of the content of this talk has been inspired by or taken directly from schools of thought outside of computer science and outside of computer vision. Black feminist scholars such as Kimberly Crenshaw and Patricia Hill Collins have introduced concepts such as intersectionality and the matrix of domination to describe the experiences of individuals living at the intersections of different axes of oppression and privilege. The concept of intersectionality has significantly informed my own thinking and has also significantly impacted the field of algorithmic fairness, having inspired the intersectional disaggregated analysis methods introduced by Timnit Gebru and Joy Buolamwini in their work on gender shades, and subsequently solidified as methods within Meg Mitchell's work on model cards. Concepts of positionality, situated knowledges, and standpoint all have deep roots in feminist scholarship, and all of these topics are things that I've touched upon within this own lecture, and which more broadly I think are extremely valuable for the field of computer vision and can help us shift towards more socially engaged and responsible field. Finally, folks within the field of computer vision, and again AI more broadly, really need to be educating themselves on systemic racism and how race and racism intersects with their own work. The urgency of this should be especially apparent at this particular moment in time, given the ongoing police violence and brutality that Black communities across this country are facing. The brutality of systemic racism is particularly visible at this moment in time, but of course this is not new, and this is also just one manifestation of a legacy of anti-Blackness that impacts every aspect of our society and most certainly impacts technology. I would really encourage folks to check out this Data and Society's writing on advancing racial literacy in tech as a place to start here. Finally, your voice in this field and as part of broader public discourse is also important. We all have a role to play in shaping public discourse, affecting change within our own academic community, and holding ourselves personally accountable for the impacts of our work. Public discourse around these issues is critical, and that's something that everybody can, and I would argue has a responsibility to take part in. This is an instance where academics and tech developers can have real impact. For example, the facial recognition ban that recently passed in San Francisco came about through discourse between civil rights groups, policymakers, engineers, and academics. We can also all be advocating for and implementing, depending on the degree of power that we each hold within this field, different incentive structures within the academic world. For example, at NeurIPS, we just saw an introduction of new guidelines encouraging folks to carefully consider ethical considerations of their work and document them in their publications. We could also imagine guidelines that describe if you publish a data set and don't provide sufficient documentation, that would be grounds for a rejection. You can imagine all sorts of different incentive structures that would shift the field towards more socially engaged, responsible practices that are driven by the harms and considerations for marginalized groups. Again, these changes don't come about through any one individual, and so many of the things that I've discussed are institutional level issues. But as an individual, you can play a role here, and as a collective, we all have the power to change and shift this field.